Hello everyone. In this video I'm going to talk about the division rule that applies for index loss. So we should know that when we have the same variable and we are dividing the variables, what should we do to the powers? So for example, here I have a square divided by a. Now, many times I have seen that students misunderstand a as a to the power of 0. That's not the case. When you just have a letter a, you should know that the power is 1. So when you have the same basis, which is a in this case, all I did is I subtracted 2 minus 1, which ends up being a to the power of 1 or simply a. So the easiest ways to remember the rule is subtract the powers. So division is associated with subtracting of powers. So my question here is 25x to the power of 6, y to the power of 4 divided by 15, x to the power of 4, y. So there are three different pieces here. So let me highlight them. Okay. The first one is just the number. Okay. The second one, you see that it is x's, okay, and then we have the y's. All right, so these are the three different groups. So focus on just the numbers. So what do I do with 25 divided by 5? So the 5 table can fit in 5 times 3, 5 times 5. So this makes it as 5 divided by 3. Now continuing your fraction, what do I do with x? X should be, I said they have to be subtracted. So 6 minus 4. And even for the y, just y by itself, please know that the power is 1. So you do have 4 minus 1. So you end up with your final answer as 5 x to the power of 2, y to the power of 3 divided by 3. So that should be your final answer. Now, when it comes, what happens when the power is bigger in the denominator, right? So if you know your integers rules, a smaller number subtracted from a bigger number, you end up with a negative power. So there is a different rule for that, and I'm going to talk about it later. But thanks guys, thanks for watching, and I will leave you with one practice question. So maybe do 3m to the power of 3 n to the power of 2 divided by 3mn, and check out your answer. Thanks guys, thanks for watching. Hello everyone. In this video I'm going to talk about laws of exponents, but I'm going to focus only on the first law, which is the multiplication rule. So before we start, I need you to know what a base and an exponent is. So for example, here you see x square. So x is your base and the exponent is 2. That is your exponent. Okay, so there are different names for exponents. We use in our speaking language, we say power, x square or x power 2, but that is where your power is. And it is also another name, which is index, and that's why it's index laws. All the laws of exponents are also called index laws. So depends on which part of the world you are, and that's the synonyms that they go around. So here is an example problem. So let's say you have p square times p to the power of 4. Now, do you see that the bases should be the same? Okay, so if the bases are the same, okay, if the bases are the same, then add your powers. Then add your powers. That's all. So the base, just keep that base and say 2 plus 4, and you end up as p to the power of 6. Now remember, the exponents are always with a smaller font compared to base, so just keep that in mind. And there you go. You have solved the first index law problem. Now, in your real problems, it would look something like this. So, p square, p power 4. So they usually don't indicate that times in between, but you need to know that when the two letters are right next to each other, that's the operation is always multiplication. Okay, this is nothing but p to the power of 4, and you end up as p to the power of 6. Thanks, guys. I hope this was helpful. Thanks again for watching. Have a blessed day. Hello, everyone. In this video, I'm going to talk about another index law or law of exponents, which is the power to power rule. So I'm going to focus on right here, this one. So what happens is, before we do, there is something that I want you to pronounce with me. So you see here, right here, I have x to the power of 2, and there are these brackets, and then there is another power which is 3. So how do you pronounce this? So we say it x square whole power 3. So the brackets must be read as whole power 3. So that's very important. What it means is this x square is covered over another power which is 3. All right, so then what happens is, according to the law, so when you have power to power, right, there's two powers here, all you have to do is multiply the powers. All right, so that's what happens. So 2 times 3 ends up being 6. Now I have an example here. N to the power of 6 whole power 2 times n to the power of 3 whole power 4. So I have to, this is a two-step process. So, and there are other more than one rule involved here. But since there is a power to power, immediately what you're going to do is you are going to multiply these two powers. Okay. So how are you going to write? This is 6 times 2 n to the power of 3 times 4. So which ends up being 12 and ends up being 12. Now, when you have same bases, right, what do, and the operation between them is multiplication, we need to add the powers. So 12 plus 12, you end up being n to the power of 24. So this is a combination problem. So initially we did have a power to power, so we removed the brackets, and then we realized that the bases are the same, so that must be added in, and this is our final answer. Hope this was helpful, guys. Thanks again. Thanks for watching. Be blessed. Hello, everyone. In this video, I'm going to talk about reciprocal rule of exponents. Now, this is very important rule, because if you want to switch a negative power to a positive power, okay, so it helps you to get rid of those negative powers. Now, you need to understand what a reciprocal is. Reciprocal is nothing but if you have a fraction, okay, so like for example, you have 5, the reciprocal of that should be 1 over 5. Okay, now all I'm doing is 5 should be treated as 5 over 1, so the reciprocal become 1 over 5. Now the same thing, so according to the rule, like if I have 5 to the power of negative 2, all it means is it's 1 over 5 to the power of positive 2. So that's how we treat it. And that ends up as 1 over 25. Okay, so what they are trying to tell you is, if you have a negative power and you want to make it a positive power, like for example, a to the power of negative n is nothing but 1 over a to the power of positive n. Now the same thing applies. If there is a negative power in the denominator, 1 over a to the power of negative n, to get rid of that, all you have to do is take it to the numerator, so a to the power of positive n. So this is the reciprocal rule for exponents. All right, guys, and it's quite helpful. And we will be doing some more examples So like for example, let's say I have x, this is just an example, okay, x to the power of negative 2 and x to the power of negative 3 and whole power 4. I'm making combination rules now. So there's a reciprocal rule here because I have negative powers, and then they have power to power rule. And I also see that the bases are the same, x, and they're in multiplication. So we are going to apply 3 different rules actually. Okay, so when you have bracket to bracket, so x to the power of negative 2 times x to the power of negative 3 whole power 4. So I have to multiply the power. So if you remember the rule, negative 2 times 4 and x to the power of negative 3 times 4. Very good. So then I have x to the power of negative 8 and x to the power of negative 12. Remember, I told you if the two letters are right next to each other, you need to treat the operation between them as multiplication. So when you have the same bases and you're multiplying them, what do you do to their powers? You are going to add their powers. Okay? Plus negative 12. And you will end up as x to the power of negative 20. But I don't want a negative power. So I'm going to bring in my reciprocal rule. And how am I going to switch that to a positive? By writing it as 1 over x to the power of 20. That's it. So this is how I applied 3 different index law rules to get my answer. I hope this was helpful. Have a wonderful, blessed day, guys. Bye-bye.